So in today's video we will talk about classification of unconformity, regional unconformity which occurs over a large area, local unconformity which occurs over a small area. Now we move to further types. First is the discontinuity. Discontinuity is between the parallel layers of sedimentary rock. It is also called as parallel unconformity. It is marked by the features of subaerial erosion, and this type of erosion leaves channels and paleosols in the rock record. Suppose this is the sedimentary layers depositing. There will be upliftment of this region like this, and there will be erosion. So this will be formed like this, and there will be a time gap where there will be no deposition. And after a few time, there will be deposition in this layer for formation of younger layers. So this is the disconformity. Older layers, younger layers. Now non-conformity. It is between sedimentary rocks and metamorphic or igneous rock, also called as heterolithic unconformity. Because it is between different rock layers, that's why it is called heterolithic. Sedimentary rocks are younger and are deposited in pre-existing eroded igneous and metamorphic rocks. Suppose there is a magma flow and this whole igneous layer is formed. Now there will be erosion of this layer. Firstly there will be upliftment, then erosion. Then this will be like this. Now sedimentary layers will be deposited over this. Now this younger layers, and this is older layer. This can be of igneous or metamorphic. This will be of sedimentary. Now angular unconformity. It is between sedimentary rocks and horizontally parallel strata of sedimentary rocks are deposited on tilted and eroded layers of older sedimentary rocks. Now suppose this was the land layers, older rock layers. There will be tectonic activity on this, so it will be formed like this now. Now there will be erosion of this layer. It will become like this. And now the younger layers will be deposited parallel, horizontal. This is the older layer that is tilted, and this is the younger layer that is straight and horizontal. So this will be the angular unconformity. There is an angular discordance between the older and younger beds, and here the older rocks are truncated at unconformity surface, means they are stopping at this unconformity surface. Now buttress unconformity. It is between sedimentary rocks. Younger sedimentary rocks are deposited against an older topographically irregular surface, resulting in younger rocks buttressing older rocks. So imagine this is the older layer of sedimentary rocks. Now younger layer will be deposited like this. This is the unconformity surface. And the difference between the angular and this unconformity is that here the younger layers are truncated at unconformity surfaces. If this was not there, it would be more extended younger layer here, but due to this the younger layers are truncated at this surface. Now we'll move to the blended unconformity. Here there is sharp contact between older and younger sequences, and it is the particular rock band don't have proper upper or lower portion. It is a type of dis or non-conformity with no distinct separation. For suppose this is the layer, the erosion of this layer, it will be like this. Now it will be deposited like this younger layer. So there is no distinction between these two layers. So materials of this will be blended in this upper layer, and the materials of this will be blended in this lower layer. That's why it is called as the blended unconformity. So we will do the further types on the basis of the relation between underlying and overlying beds. Firstly, what is marine transgression and regression? Transgression when the sea level has a high tide. High tide means suppose this is the shoreline, this is the ocean. When it fully covers this shore, it reaches till here. This is called a high tide, and this stage is called a marine transgression. And what is marine regression? When the sea level decreases to here, it will not cover this shoreline. This will be called as marine regression. High tide means the ocean or sea water rise to the highest level and covering most of the shoreline. And low tide means the shoreline is revealing. And now we move to overlap. Overlap results due to marine transgression, and it is formed in high tide. And sediments get deposited by water, forming layer which progressively overlaps the older layer. Suppose this is the older layers. The sea level will be rise to this, sediments will come, and this will be deposited like this. So the younger layers are completely overlapping the older layers. And now overlap. It results due to marine regression formed in low tide. And here suppose this is older layer. The sea water is not coming enough to the shoreline, coming here depositing sediments. So layer will be formed like this. So older layers would be like this. Older layers would be like this, and younger layers, as water is coming till here only in regression. So younger layers, here the older layers are extending further beyond the younger ones in the diagram. And the overstep, it results due to marine transgression, and the younger series of beds are in the contact with the older series. So we can see the beds here, the U is the younger bed and A is the older bed. They are in contact, and there is also angular discordance between them. Then onlap, it has the characteristics of both overlap plus offlap, and the younger series are in contact with the younger series only, and older ones with the older. Now we'll move towards the outlier.